Respected Director, NPSCI Pytharagar, Dr. Ambarish Sharan Singh, Convener of the webinar, Dr. CNS and Mr. Divya Didi, Co-convener of the webinar, Dr. Das, Mr. Ravi Pandey, and Mr. Pankaj Gish, and all organizing committee members. Myself, Mrs. Taru Mahara, welcome you all for the 3 days webinar Institute, Pytharagar. It is a holy tradition to worship our goddess Saraswati before any important event. So let us dedicate our prayers to Saraswati and seek her. Sir, will you have the AV, please? Due to some technical issues, there has been some delay in playing the video. So let's start with the event. Now, in this era of knowledge, the higher education institutes are not restricted just to knowledge transfer from teachers to students only, but also involve knowledge assimilation, knowledge generation, and knowledge dissemination. This webinar is to bring together innovative academicians, industrial experts, students, and hobbyists in the field of climatology and meteorology to a common forum and sharing their valuable findings and thoughts. Now, we have among State Meteorological Center, IMD, Dehradun, and his area of specialization is weather forecasting. He has several research publications related to weather forecasting and has written many books like Standard Operating Procedure Document for thunderstorms. He has received appreciation from DGIMD for successful organization of the inaugural function of Integrated Forecasting and Communication System. He has also received appreciation from DGIMD for organization of media workshop and tropical cyclone workshop in 2011 and 2012 respectively. Sir, I would like to request you to kindly share your valuable knowledge with us. Sir, please.
Hello, hello. Am I audible? Hello.
Yes, sir.
Hello. Am I audible? Hello. Hello.
Yes, sir. Yes, sir.
Can you hear me?
Yes, sir.
So I can start.
Yes, sir, you can start.
Okay. Okay. Very good morning to all the present dignitaries, participants, and scientists who are to give the lectures during this 3 days webinar. So very good morning to all of you. आज इस देवभूमि उत्तराखंड की पुण्य भूमि पर और कैलाश मानसरोवर के पवित्र पद पर स्थित नन्ही परी सीमांत इंजीनियरिंग कॉलेज पिथौरागढ़ के डायरेक्टर विद्यार्थी जी और वेबिनार के संयोजक डॉक्टर नेगी व उप संयोजक डॉक्टर गिरी, प्राध्यापकों, अन्य जुड़े हुए महानुभावों, इंजीनियरिंग छात्र छात्राओं, आप सभी को मेरा हार्दिक अभिनंदन। तो आज के इस वेबिनार की जो आपने विषय रखा है, तो आपने क्लाइमेटोलॉजी और मीटेरोलॉजी को चुना है, जो कि आज के संदर्भ में बहुत ही उचित एक विषय है। और जो पिथौरागढ़ आप देखते हैं कि जो है शीत ऋतु की जो इस समय चल रही है और उसकी पराकाष्ठा को झेलने वाले पिथौरागढ़ जो स्वयं में जलवायु विज्ञान एवं मौसम विज्ञान के लिए एक प्रयोगशाला है, तो मैं जलवायु एवं मौसम विज्ञान विषय पर वेबिनार के आयोजन के लिए आप सभी को हार्दिक शुभकामनाएं देता हूं। आज पूरा विश्व कोरोना जैसी महामारी से जूझ रहा है। हर सरकार एवं संस्थान मानवता को महामारी से बचाने के लिए प्रयास में लगे हैं। उसी बीच यह भी आवश्यक है कि हम विकास तथा आगे बढ़ने के हौसले को कम न होने दें। द शो मस्ट गो ऑन के चरितार्थ करते हुए यह कार्यक्रम आयोजित करने के लिए कॉलेज प्रशासन, प्राध्यापक एवं आयोजक बधाई के पात्र हैं। विज्ञान की खोजों एवं आविष्कारों की जानकारी तथा लाभ अधिक से अधिक लोगों तक पहुंचाने के उद्देश्य सफलतापूर्वक पूरा होगा, यह सभी प्रतिभागी विचार करें विचारों का आदान प्रदान कर लाभान्वित होंगे, ऐसा मेरा विश्वास है। जलवायु विज्ञान तथा मौसम विज्ञान एक ही विषय के विज्ञान हैं और ये सब जो है एटमॉस्फेरिक साइंसेस के अंतर्गत आते हैं, जिसमें कि आपको एक कह सकते हैं कि पूरी एटमॉस्फेरिक फिजिक्स है या एटमॉस्फेरिक केमिस्ट्री से लेकर के या ओशियनोग्राफी है या फिजिकल ज्योग्राफी भी है, तो ये सब उसी के जो है पार्ट जो है बन जाता है जलवायु विज्ञान और मौसम विज्ञान के। किसी देश अथवा क्षेत्र विशेष की विशेष समय अवधि में रहने वाले मौसम को आप जो है वेदर किसी विशेष समय में या ये कह सकते हैं कि पर्टिकुलर टाइम पे जो चीजें होती है उसको तो आप जो है मौसम बोलेंगे, वहाँ का वेदर बोलेंगे। लेकिन अगर उसी चीजों का आप एक लंबे समय के लिए एवरेज कर लें तो वो वहाँ का जो है उस लोकेशन का और एक ज़्यादा पीरियड के लिए आप उसको करेंगे तो वो वहाँ की क्लाइमेटोलॉजी जो है फिर बन जाती है। तो बिल्कुल क्लाइमेटोलॉजी और मीटेरोलॉजी एक दूसरे के पहलू हैं, सब एक दूसरे के अंतर्गत ही आते हैं। मीटेरोलॉजी मैं कहूँगा कि वाइडर सब्जेक्ट हो गया, जिसके अंदर आपको चाहे मौसम है चाहे क्लाइमेटोलॉजी है, सबको आप स्टडी करते हैं। मीटेरोलॉजी में ज़्यादा जो फोकस रहता है वो फोरकास्टिंग के पर रहेगा, पूर्वानुमान पर रहेगा, जो जिससे कि क्योंकि लोग ये जानना चाहते हैं कि आगे किस तरह की एक्टिविटी होने वाली मौसम की वजह से और वो किस तरह से उनको प्रभावित करेगी, तो इसके बारे में लोगों को सटीक जानकारी की बहुत आवश्यकता होती है। तो इसी क्षेत्र में जो है जो हमारा विभाग है वो तो काम करता है। तो आज इस जो वेबिनार हो रहा है क्लाइमेटोलॉजी और मीटेरोलॉजी पे, तो मेरे को जो है मुख्य अतिथि आपने आमंत्रित किया है, तो इसके लिए मैं पूरे संस्थान और उसके जो डायरेक्टर हैं डॉक्टर विद्यार्थी, आप सबका मैं आभार रखता हूँ, आभार कर व्यक्त करता हूँ। मीटेरोलॉजी का महत्व कई गुना बढ़ जाता है आज के समय में। मौसम विज्ञानियों के ऊपर बड़ी जिम्मेदारी है कि वे ऐसे टूल्स खोजें तथा उपलब्ध जानकारियों को ऐसे विश्लेषण करें कि मौसम की सटीक से सटीक भविष्यवाणी की जा सके। सन 2004 में सुनामी तूफान की वजह से एशिया के बड़े क्षेत्र को प्रभावित किया था। उससे व्यापक विनाश एवं जनहानि भी उस दौरान हुई है। लाखों लोग मारे गए थे। अगर सही समय पर ऐसी सुनामी का पूर्वानुमान लगाया जा सकता तो शायद सारी जनहानि को कम से कम बचाया जा सकता था। तो जो सुनामी आई थी, तो जैसा आप सभी को पता भी है कि वो भूकंप की वजह से ही हुई थी। तो भूकंप की वजह से जो है जब सरफेस जो ओशियन के नीचे का सरफेस है वो हलचल करेगा, उठेगा या दबेगा, तो क्या होगा कि जो पानी है एकदम से जो है बाहर को या फिर अंदर को जो है उस एरिया में वो जाएगा। तो उसी की वजह से भी जो फॉर्मेशन ऑफ वेव्स होता है वो बहुत बड़ी वेव्स बनती हैं और जो कि कोस्ट तक चल के आती हैं, तो उसकी वजह से बहुत ज़्यादा नुकसान वो करती है। तो 2004 में ऐसा ही देखा गया था और उसके बाद जो है भारत सरकार ने और अन्य देशों के साथ भी जो एक तालमेल बना करके उसके लिए एक सिस्टम जो है लगाया गया है। तो अब जब भी इस तरह की हलचलें होंगी तो आपको जो है एक फुल प्रूफ एक सिस्टम रखा गया है जिसमें कि जो है आपको जैसे ही हलचल होगी आपको सूचना मिल जाएगी और आपको कुछ समय मिल पाएगा कि आप जो है कम से कम उसको जो है लोगों को बता पाएंगे कि हाँ इस क्षेत्र में सुनामी का प्रभाव आ सकता है, तो आप यहाँ से जो है हटने की कोशिश करें, बचने की कोशिश करें। तो ये काफ़ी महत्वपूर्ण आगे हमको जो है सहायता करेगा। तो यह बिल्कुल है कि सभी संस्थानों, देश एवं अन्य देशों के साथ भी तालमेल करने से इस तरह की जो आपदा हैं उसमें कहीं ना कहीं फिर हम जो है वैज्ञानिक तरीके से बढ़ते हुए उसको कम कर सकते हैं, उसके प्रभाव को कम कर सकते हैं। बाकी आपने अभी भी इस वर्ष आए अम्फान तूफान के बारे में भी सुना होगा, वो उदाहरण सामने है। तो उस तूफान की वजह से भी काफ़ी हानि हुई है, लेकिन जनहानि को बिल्कुल कम किया गया है। आप ये कह सकते हैं कि कुछ लोगों के उसमें जो है मैं कहूँगा कि सिंगल डिजिट में कुछ नुकसान जरूर हुआ है, जान का भी, लेकिन बहुत कम। जबकि एक समय था कि एक कोई तूफान जो है, जो स्ट्रॉन्ग है, साइक्लोन जो है, किसी भी तट पे आता था, चाहे वो भारत की बात करें या अन्य देशों की भी बात करें, तो उसमें लाखों लोग चपेट में आते थे, लाखों लोगों की जान जाती थी। और आज विज्ञान ने खासकर जो फोरकास्टिंग है, कहेंगे कि मीटियोलॉजी है, उसने इतना अच्छा प्रोग्रेस किया है कि अब काफी लीड टाइम मिल जाता है, काफी समय पहले जो है सटीक जानकारी लोगों को दे दी जाती है, या प्रशासन को दे दी जाती है, या कहीं के जो डिजास्टर मैनेजर्स है उनको वो चीजें पहुंचा दी जाती है, जिसके आधार पर फिर वो जो अपने पूरे ताकत के साथ जो है जो आपको प्रबंधन उसमें करना है कि कैसे लोगों को बचाना है, कहाँ शिफ्ट करना है, तो वो उस चीज के लिए उनके पास समय मिल पाता है और टाइम रिएक्शन हो जाता है। तो आज हम देख रहे हैं कि तूफान की वजह से जो है जो जान की हानि होती थी वो बिल्कुल ही नगण्य के बराबर हो गई। तो आप जानते हैं कि मीटियोलॉजी के इसी चीज को देखते हुए आज हर आदमी को इसकी जो है कहीं ना कहीं जरूरत है, चाहे उसका खेती किसानी का काम है, वहाँ पे भी उसको जरूरत है कि मौसम की उसको जो जानकारी मिले और वो अपनी फसल को कैसे मौसम की मार से भी बचा सके, या उससे जो लाभ उसको मिल सकते हैं वो उसका फायदा वो कैसे उठा सके। तो इसके लिए भी वो बहुत जरूरी, उसके लिए किसान के लिए मौसम की जानकारी होना बहुत जरूरी है। दुनिया के आज मनुष्य दुनिया के हर क्षेत्र में अपने कदम बढ़ा रहा है, अपना कार्य क्षेत्र बढ़ा रहा है, जिससे कि मीटियोलॉजी की जो महत्व है वो और भी बढ़ जाता है। मौसम विज्ञानियों के ऊपर बड़ी जिम्मेदारी है कि वे ऐसे टूल्स खोजें तथा उपलब्ध जानकारियां का ऐसे विश्लेषण करें कि मौसम की सटीक से सटीक भविष्यवाणी हो पाए। अतः मौसम विज्ञान सच्चे अर्थों में मानवता की प्रत्यक्ष रक्षा करने वाला विज्ञान है। इसके जो आज इसमें एडवांसमेंट हुए हैं इस साइंस में, उसकी वजह से चाहे आप कोई भी क्षेत्र ले लें, बहुत से ऐसे क्षेत्र हैं जिसको कि बिना मौसम की जानकारी के वहाँ काम वो नहीं कर सकते। जिसमें कि सबसे बड़ा अगर मैं बात करूँ तो एविएशन इंडस्ट्री ऐसी है, जो हवाई यात्रा है या हवाई कोई भी ऑपरेशन है, तो उसमें मौसम की सटीक जानकारी बहुत महत्व रखती है। तो उनके लिए भी वो बहुत ज़्यादा वैल्यू रखती है वो चीज़ जो है। उसी की वजह से आप देखते हैं कि जब भी मौसम खराब होगा तो आप देखते हैं कि सबसे पहले जो फ्लाइट्स वगैरह है वो बंद होती है, क्योंकि मौसम की थोड़ा भी गड़बड़ होने पे एक अगर एक्सीडेंट होता है तो आप देखते हैं कई करोड़ों का नुकसान जो है पल भर में जो है वो हो सकता है। वो ऐसे क्षेत्र हैं, चाहे आप एविएशन इंडस्ट्री बोल लीजिए या शिपिंग इंडस्ट्री बोल लीजिए या यातायात वाले जो और भी चीजें हैं, तो वहाँ पर भी मौसम की बहुत बड़ी सटीक जानकारी की जरूरत है। इसके साथ साथ कृषि है या आपदा प्रबंधन है, तो उसमें भी वो उतना ही महत्वपूर्ण आज के समय में है। लोग चाहते हैं कि उनको समय जो है जानकारी मिल जाए और जिससे कि वो अपने जान माल की सुरक्षा कर सके। उत्तराखंड प्रदेश विकट भौगोलिक परिस्थितियों वाला प्रदेश है। यहाँ पर मौसम विज्ञान की सटीक भविष्यवाणी आम जन को काफी राहत दिला सकती है। हमने 2013 की केदारनाथ आपदा को झेला है। मौसम पूर्वानुमान के आधार पर निर्णय लेकर ऐसी आपदाओं से जनहानि को रोका जा सकता है। उस समय भी आपने देखा है कि इस तरह की बारिश होने वाली, इसके लिए भविष्यवाणी दी गई थी, पर कहीं ना कहीं शायद थोड़ा जो डिजास्टर मैनेजर्स है उनके मन में एक हो रहा कि ठीक है, बारिश तो उत्तराखंड में हमेशा ज़्यादा होती है और इस बार भी हो रही, तो शायद इसका कुछ ऐसा प्रभाव नहीं होगा। लेकिन उस थोड़ी सी चूक से आप देख सकते हैं कि कितनी बड़ी जनहानि इस समय हम लोग को उठानी पड़ी है। विश्व के एक क्षेत्र की भौगोलिक घटना का प्रभाव दूसरे क्षेत्र पर अवश्य पड़ता है। सुंदर अंटार्कटिका में छोटी हलचलें उत्तराखंड पर व्यापक असर डाल सकती है। तो इसमें ये कहेंगे कि जैसे आप जो स्नो कवर है, तो चाहे वो साउदर्न हेमिस्फीयर का है चाहे वो नॉर्दर्न हेमिस्फीयर में है, तो वो भी एक पैरामीटर है कि जो ये बताता है कि इस बार मानसून सीजन किस तरह का हो सकता है। तो वो भी पैरामीटर उसमें मानसून की फोरकास्ट के लिए दिया जाता है। दक्षिण प्रशांत महासागर में उपस्थित वायु दाब एवं एवं हवाएं हमारे देश के मानसून को प्रभावित कर सकती है, जो देश के वर्ष भर के मौसम को बदलेगा। बाढ़ या सूखे जैसे हालात बनेंगे। अंततः फसल चक्र तथा उत्पादन प्रभावित होगा। तो ये सभी चीजें जो भी वेदर सिस्टम है या जो इंडिकेशन वो हमको देते हैं, तो उसके आधार पर ही आप देखते हैं कि आगे जो फोरकास्ट है वो आप ये कह सकते हैं कि फोरकास्ट की जो रेंज है अलग अलग है। आप एक दिन की फोरकास्ट देते हैं, आप कुछ घंटे की भी देते हैं, फिर आप मीडियम रेंज तक देते हैं, 10 दिन तक की, 8 दिन तक की आप फोरकास्ट दे रहे हैं, मंथ तक की है या सीजन की है। तो भारत मौसम विज्ञान विभाग जो है जो सीजनल फोरकास्ट है वो भी वो इशू करता है, खासकर मानसून सीजन के। तो आप ये कह सकते हैं कि दक्षिण पश्चिम में जो प्रशांत महासागर है वहाँ में जो हलचल होती है और उसकी वजह से हमारा मानसून जो है प्रभावित होता है। तो आपको पता है, जैसे आप लोगों ने सुना भी होगा, ला नीना और एल नीनो के नाम आपने सभी ने सुने होंगे। तो इसका असर जो है हमारे मानसून के रेनफॉल पर पड़ता है। आप देखते हैं कि जब एल नीनो ईयर रहेगा तो उस साल सूखे वाली स्थिति बन जाती है, बारिश कम होती है, ज्यादातर भूभाग ऐसा रहता है कि जहाँ पे बारिश की कमी हो जाती है। लेकिन अगर ला नीना होगा तो आप देखते हैं कि उस वर्ष जो है अधिक वर्षा हो जाएगी, अच्छी बारिश होगी और जो हमारा कृषि प्रधान है या कहिए कि मानसून पे हमारी इकोनॉमी जो है, हमारी जो पूरी आर्थिक गतिविधियां हैं, तो एग्रीकल्चर पे ही ड्रिवन है। अगर एग्रीकल्चर में अच्छा प्रोडक्शन है, अच्छी चीजें हो रही हैं, तो फिर उसका लाभ जो है पूरे देश को ही मिलता है। तो इसीलिए जो मानसून की फोरकास्ट है या मानसून की जो भविष्यवाणी है, पहले से ही अ, अ, अनुमान करने के लिए यह केवल न किसानों के लिए अच्छी एक जो है जानकारी उपलब्ध कराता है, बल्कि साथ ही जो हमारी सरकार है उसको जो पॉलिसी डिसीजन मेकिंग में वो हेल्प करता है। अगर आपको जो है, जब आप सीजनल फोरकास्ट मानसून की देंगे और आपको दिख रहा है कि हाँ इस बार मानसून जो कम रहने वाला है, तो गवर्नमेंट उस पर डिसीजन लेती है कि हाँ हमको जो है अनाजों की कमी होगी तो हमको आयात करने पड़ेगा। ऐसी सब स्थितियां हैं जिसकी वजह से कि जो मेट्रोलॉजी का जो महत्व है वो दिन प्रतिदिन लोगों के लिए बढ़ता जा रहा है। जलवायु विज्ञानियों एवं मौसम विज्ञानियों को लगातार मौसम की डेवलपमेंट पर नजर रखनी पड़ती है। केवल एक दिन या माह तक का नहीं, जैसे मैंने बताया सीजन तक की जो है फोरकास्ट हमको जनरेट करनी पड़ती है, देनी है। तो पूरे आप देखते हैं कि जो फोरकास्ट है एक इतना आसान तंत्र तो नहीं है। आप देखते हैं कि पूरा ग्लोब को आप लेकर के ऑब्जर्वेशन लेंगे और उस ऑब्जर्वेशंस को प्रोसेस करना है और प्रोसेस के बाद आपको जो है, चाहे वो फिर शॉर्ट रेंज की है, मीडियम रेंज है, लॉन्ग रेंज है, या फिर आप जो है सीजनल फोरकास्ट जो है वो सभी चीजें बनाते हैं। तो इसकी वजह से जो है आप कह सकते हैं कि जो मेट्रोलॉजी और क्लाइमेटोलॉजी है उसका बहुत महत्व जो है आज के जनमानस को है। जलवायु में असाधारण परिवर्तन तथा मौसम में अस्वाभाविक उलटफेर आज चिंता का विषय है, लेकिन उसके लिए मनुष्य की कारगुजारियां दोषी है। तो आप जैसे देख रहे हैं कि आज के युग में जो ग्लोबल वार्मिंग है या क्लाइमेट चेंज है, ग्लोबल ग्लोबल वार्मिंग की वजह से, तो उसके कहीं ना कहीं दुष्परिणाम परिणाम हम लोग को देखने को मिलते हैं। तो अत्यधिक कार्बन एमिशन की वजह से आप देख रहे हैं कि जो वेदर पैटर्न्स है उसमें कहीं ना कहीं जो वेदर पैटर्न में जो है चेंजेज आए हैं और उसकी वजह से ओलावृष्टि से लेकर के बादल फटना से लेकर के तेज बारिश से लेके और बड़े शॉर्ट पीरियड में जो तेज बारिश हो जाती है जिसको आप बादल फटना भी फिर कहते हैं, जिसमें कि 10 सेंटीमीटर या उससे अधिक बारिश जो है 1 मिनट में अगर मिल जाती है, तो ऐसी चीजों को हम लोग जो है बादल फटने वाले कैटेगरी में हम रखते हैं। तो वैसी जो चीजें हैं आज के दिन वो देखने को मिल रही है। तो उन उन चीजों का सटीक पूर्वानुमान हम दे पाए और लोगों को उसका अधिक से अधिक फायदा मिले, तो यही हमारा उद्देश्य है। तो ऐसी जो और भी दिक्कतें आ रही है जो कार्बन एमिशन की वजह से एनवायरमेंट में या ये कहिए कि जो जलवायु में जो परिवर्तन आ रहे हैं, तो वहाँ पर कहीं ना कहीं जो इंजीनियरिंग है या जो टेक्नोलॉजी है उसका एक बहुत बड़ा रोल है। वो ऐसी चीजें खोजे, ऐसी चीजों को डेवलप करें जिसकी वजह से कि जो कार्बन एमिशन है जो एटमॉस्फेयर में हो रहा है वो कम से कम हो सके। तो ऐसी 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 टेक्नोलॉजी की हमको बहुत ज़रूरत है। तो उसमें जो इंजीनियरिंग के छात्र हैं या इंजीनियरिंग से जो संस्थान है, तो उनका भी दायित्व जो है बहुत ज़्यादा बढ़ जाता है। तो उनको ऐसी टेक्निक्स पे काम करना है कि जिससे कि हमें आने वाले समय में जो कार्बन एमिशन है उसको कम से कम किया जा सके। भारत ने पेरिस एग्रीमेंट में भी कदम रखे हैं और उसमें काफ़ी आगे तक भी वो कोशिश हम कर रहे हैं, हमारा देश कर रहा है। हमारे प्रधानमंत्री जी ने भी सोलर अलायंस का विचार रखा है और उस कार्य को काफ़ी आगे बढ़ा भी दिया है। तो सोलर एनर्जी एक है, जैसा आप देख सकते हैं कि क्लीन एनर्जी है और कार्बन एमिशन इसमें कम से कम हो जाएगा। जो भी और चीज़ों से रिलेटेड है, कहीं ना कहीं थोड़ा एमिशन होता है, लेकिन जो आज आप देख रहे हैं जो फोसिल फ्यूल की वजह से जो कार्बन एमिशन है वो सबसे ज़्यादा है। तो ऐसी टेक्नोलॉजीज की ज़रूरत है कि जिसमें कि जो है क्लीन एनर्जी हमको मिल पाए, जिससे हमारा विकास भी हो लेकिन विनाश को कम किया जा सके। भारत ने लक्ष्य रखा है कि कार्बन उत्सर्जन में पेरिस समझौते से भी आगे जाकर सोलर एनर्जी पे भारत की प्रगति बहुत तेजी से हुई है, जिससे कि जो है जो पेरिस एग्रीमेंट है उसके अनुसार हम जो है हमारा देश जो है काफी तेजी से उस पर काम भी कर रहा है। इंजीनियरिंग और टेक्नोलॉजी के लिए भी नए अवसर, जो इस तरह की चीजें देश जिस डायरेक्शन में आगे करना चाहता है, तो वहाँ पर भी इंजीनियरिंग और टेक्नोलॉजी का बहुत बड़ा रोल होगा। इंजीनियर्स अपने स्टार्टअप में पर्यावरण को स्वच्छ रखने में महत्वपूर्ण भूमिका निभा सकते हैं। तो जो भी आप देख रहे हैं कि आज काफी एंथुजियास्टिक है हमारे स्टूडेंट्स जो है, वो एक ग्रुप बना करके और अभी जो रोजगार के लिए एक गवर्नमेंट ने इस तरह की चीजें रखी है कि स्टार्टअप से आप एक शुरुआत करिए और आप खुद भी रोजगार पाए और लोगों को भी रोजगार दें, और उसमें ऐसी चीजें खासकर हों कि जो लोगों के अधिक से अधिक जो है फायदा करे। तो वो चीजें भी इंजीनियरिंग जो है उसमें एक बहुत बहुत महत्वपूर्ण भूमिका निभा सकते हैं। विज्ञान के क्षेत्र में सभी कुछ आपस में जुड़ा है। एक विज्ञान किसी न किसी रूप में दूसरे विज्ञान को सहायता देता है। आप लोगों की खोज तथा आविष्कार मौसम विज्ञान को भी मदद करेंगे। विज्ञान का पूरा क्षेत्र मानव जाति के लिए कल्याण के लिए आगे बढ़ाएगा। विज्ञान के प्रचार प्रसार एवं सकारात्मक उपयोग में आप लोग निरंतर आगे बढ़े, यही मेरी शुभकामना है। धन्यवाद, नमस्कार। तो इन्हीं शब्दों के साथ मैं अपनी वाणी को विराम देता हूं और जो आगे का कार्यक्रम है उसको शुरू किया जा सकता है। तो आप सभी को एक बार पुनः बधाई इस वेबिनार को आयोजन करने के लिए। नमस्कार।
Enlighten us with your opening remarks on this webinar and sharing your valuable knowledge with us. Now, we have Dr. Narendra Singh, who is a very renowned person of his Science E, Atmospheric Science Division, Research Institute of Observational Sciences, Nainital. He is PhD in Atmospheric Sciences from Indian Institute of Tropical Meteorology, Pune. His research interests include radar meteorology, lower atmospheric dynamics, Himalayan meteorology, micrometeorology of complex terrain, boundary layer characterization, climate change, and extreme weather events, transport of pollutants to Himalayan region, etc. He has more than 4 years of experience in radar study operation journals and has written one book. He has been awarded the 29th National Laser Radar Conference and full grant to attend the workshop on applications of atmospheric modeling air pollution impact research in South Asia held in Kathmandu, Nepal. He is in charge of Aries Recreation Club and state coordinator for Vidyarthi Vigyan Manthan, India. Your
Hello. Hello. Hello.
Hello.
Hello, Nigiji, am I audible?
Haji, yes.
Okay, so shall I start share?
Yes, sir.
Okay, is my screen visible?
Yes, sir.
Okay, that is much of the bandwidth, so let us stop video. Only audio mode is okay? Or video is okay?
Without video.
So, first of all, yeah, hello.
Without video is okay.
Okay, no problem. Okay, anyway, let it be. Let it go at one corner. If I'm audible to all. So, well, I missed many of the previous discussions anyway. So I would like to thank, first of all, to the director, Nannipari Simant Engineering College, Dr. Vidyarthi ji, and of course, Negi ji, who has been quite instrumental in organizing the relevant program, which is very close to my heart, the subject as meteorology and climatology. The point is that I think the previously Dr. Vikram Singh also described a little bit about what is the meteorology and sort of climatology. So I'll be dealing with the very basic lecture in very basic things in my first lecture. So as the topic you have suggested, it is, I mean, already you have decided that it will be meteorology and climatology. So before going into the meteorology and climatology, which is actually more, sub-discipline of atmospheric science, so I would start with very basics of the atmospheric science. Okay. So, Negiji, may I know how many participants are there? I just for my curiosity, so that I can get a better connect with the people. If I am audible. Hello.
What will you?
Okay, so means people are able to listen, right? Oh, there is, I think, a lot of issues in transmission. Okay. So anyway, atmospheric science basically is consisting of two major sub-disciplines. And first, let us talk about atmospheric science. So atmospheric sciences are basically the disciplines of science or the physics that deals with purely with the atmospheric issues, right? So the atmospheric sciences is basically again divided into two major disciplines. One is meteorology and other is climatology. So meteorology is basically, if we talk about meteorology, meteorology deals with meteor plus logos. Meteor means something which is related to the atmosphere, and logos something which is lofty. I mean when we talk about the atmosphere, so study of atmosphere is basically meteorology. And then we talk about climatology. So climatology comes from the climate. So then again we have to consider two terms, weather and climate. So weather is the day-to-day changes in the measurable parameters like temperature, pressure, humidity, rainfall, etc. Whatever we see every day, we call them weather parameters, or in the simple layman language, if we talk about, we see what we see today is weather, what we expect tomorrow is climate. So this is the difference what we can understand between weather and climate. And then when we talk about climatology, logy means any something, study of or a particular discipline, a study of a particular discipline we call logy. So climatology means study of climate is climatology in general. And similarly, study of the atmosphere is meteorology. So meteorology is again divided into three subdisciplines. One is the meteorology, other is synoptic meteorology, and then third one is dynamic meteorology. So the physical meteorology, if we talk about in general, so physical meteorology basically deals with the structure and composition of the atmosphere. Since we are living on the surface of the earth, we have a gaseous envelope surrounding us. And if we talk about this gaseous envelope and its composition, so we have to think two ways. One is, what is the vertical extent of this gaseous envelope that we call atmosphere, and secondly, what is the composition, what are the elements present in that atmosphere or the gaseous envelope that we talk about, usually we talk about. And the branch of meteorology that deals with this, we call this physical meteorology. Basically related to the physics and chemistry of the atmosphere, we call that physical meteorology. Then when we talk about synoptic meteorology, so synoptic meteorology is the word, if you see synoptic, it's consisting of synchronized, or if we take the first three letters, it is basically something which is synchronized with something, and optic means something related to the observation. So synoptic meteorology means if we are trying to observe the atmosphere simultaneously at many locations and try to put that information on a plain paper, and we call it a chart, so, and then if we try to interpret that observation and see that what is happening, say, over hundreds of kilometers to thousands of kilometers, then we'll be talking exactly about synoptic meteorology. Means the description and forecast, which is related to analysis, description, and forecast of a weather parameter. So we call that synoptic meteorology. Basically, this deals with the analysis, description, and forecast of weather phenomenon, like which are mainly of large scale. These are not of, say, 10 kilometer or less than 1 kilometer, what is happening within 1 kilometer or 10 kilometer, but of course it deals with the larger scales motions of the atmosphere. For example, monsoon is a synoptic scale phenomenon. It is not a mesoscale or micro scale, but it is a synoptic scale. It is a large, like western disturbance again is a synoptic scale feature of the weather, like the rain that we are receiving nowadays in the winter time, which is originating somewhere in the western Mediterranean Ocean, and then Mediterranean Sea, and then these weather systems traveling towards Himalaya, or say in the foothills Himalayas up to Delhi NCR. So these are actually again spreading, say, in few hundreds of kilometers to thousands of kilometers, up to thousands of kilometers, and we call them synoptic meteorology, and the synoptic systems basically. And these systems are studied in a branch of science that is called synoptic meteorology. Now, if we come to the third and the last discipline of meteorology is dynamic meteorology. The first thing is physical causes like physics and chemistry of the atmosphere. Second is analysis, forecast, or say description and forecast of these systems. These are synoptic meteorology. And then when we deal with the third system, which is dynamic meteorology, here we have to frame some equations. We have to use analytical approach to understand the motions of the atmosphere, like fluid mechanics. Fluid mechanics is applied, say, from astrophysical astrophysical processes to say liquids or everywhere. So this is again, if we consider atmosphere is again a fluid which is consisting of air and moisture and mixture of many other gases. So this fluid has to be dealt with some sort of equations which we call analytical equations. I mean, analyzed or sometimes solved analytically, but not always possible to solve all equations analytically. So, but then whatever equations comes into picture, or we employ the basic systems like basic conservation laws, conservation of momentum, conservation of energy, conservation of mass, or starting from this second law of motion, Newton's second law of motion, we apply all these basic laws to solve the problems of atmospheric science or to deal the atmospheric science when fluid is in motion. So that branch deals with the meteorology, it's called dynamic meteorology, which deals with the analytical approach of the system. So we try to employ all these equations and try to solve them analytically in order to understand the physical principles happening in the atmosphere, or to deal with the atmospheric motions, say from small scale to synoptic scale, or sometime of the order of the planetary scale. So this is the branch that deals with the dynamic meteorology. Dynamic means moving, basically. So atmosphere is most of the time in motion, and we require some set of equations to understand the motions. Like, for example, we have three components of the wind. Wind is either blowing from east to west or west to east. When it is blowing from east to west, we call it easterly wind. When it is coming from the west, we call it westerly wind. Similarly, when the wind, and we call it zonal component. The wind, because earth is rotating from west to east, so there is always flows either easterly or westerly. But then again, from starting from equator or say tropical region to mid latitude region, say from, we call tropical region from equator to 30° north or 30° south, then we 30° north to 60° north or south, either way it is mid latitude region geographically if you talk. So all, and then polar region from 30° north to 30° north or south, either way. So these are geographical or meteorological classifications of these regions, and every region is having its different meteorology. For example, if we talk about the tropics, the winds in the tropics at surface level, say up to 3 to 4 kilometers in the vertical, are coming from the east. We call them easterly, other than monsoon. But as soon as monsoon comes, which is a synoptic scale system, winds reverse, right? So the direction of the wind changes. Winds becomes westerly in the lower part of the atmosphere. And sometime monsoon is also defined as reversal of the winds is monsoon. If simplest definition, if you talk about monsoon. So these motions are to be studied under dynamical meteorology. And again, as I told you, that wind has three components. It is having zonal component, meridional component. Meridional means from north to south flow. We call that meridional component. And then, of course, vertical component, like when earth is heated up very fast, or sometimes in the winter time, so it leads to the convection. Like for me, in mountains, if you see, there are thunderstorms quite often in the afternoon. So these thunderstorms are originating basically as a result of the convection, which is the vertical motion of the atmosphere. That how does atmosphere from the surface goes up higher up into the atmosphere, say up to 6 kilometers in the vertical. So that is where we have to understand all these issues, that what is the W component of the wind, then divergence, vorticity, all these equations come into dynamic meteorology. And then now we come to the climatology. So climatology, again, as I told you, that the study of the climate basically comes in climatology. And climate is not a 1 day or 2 day sort of phenomenon. Climate is long-term statistical property of measurable parameters. For example, temperature, pressure, or rainfall that we usually deal with. If we talk about climate, so everybody will say, okay, it's very hot there, or it is very cold there, or it is most of the year it is raining there, and it is not raining at the other time. So we have to understand that sense. So climate in general, when we talk about the climate or climate change related studies, we consider that the minimum change that we are expected, or the minimum period in which a climate is supposed to change or see some sort of effects of any activity, whether it is anthropogenic or natural, it is basically a 30 years of epoch. So if we talk about study of climate, so we have to at least wait for 30 years. That, for example, if you are sitting at Pithoragarh and you ask the people who have been there for years and generations, So you ask your grandparents that what was the temperature, maximum temperature on 15th June at Pithoragarh. So he'll say, no, it was very cold. We used to wear sweaters and coats or warm clothes, etc. But then if you talk down the line 30 years, for example, today or this year or the coming year, 15th June, and then check the temperature difference between the two. The maximum temperature, which was 30 years ago, and the maximum temperature on a given day, say 15 June, which is, for example, today or the coming 15 June over Pithoragarh, then you'll see the difference. So this 30 years of period is considered one climatic epoch. So whenever we talk about climate change studies or climate study, at least we have to have 30 years of data. Now again, climatology is having three subdisciplines, subcategories. The first one is physical climatology. Again, if climate is changing, say over the period of 30 years, how would you like to then find out the causes, and how would you deal with it? So the physical climatology is the branch of climatology that deals with the underlying physical causes. Means what is the physics behind the change in climate? So that study is carried out in this branch. Next is climatography. Now, since climate is not changing, for example, over a single location or over a given latitude or longitude, but climate change nowadays, if you see, it is widely understood, or it is unequivocal to say that climate is changing. There was a lot of debates in the past that some people said in 80s that no, there is no climate. But now climate change came into being, and global countries from all over the globe participated in that, and they decided that definitely there is change in the climate, and climate is definitely changing. So then people realize that, of course, we have to understand this. So the climatography is basically, if we have we have to consider, say, area starting from Indian subcontinent to, say, up to European region, about 3,000 kilometers, and up to in the length, and say 2,000 kilometer in the breadth, or say latitude longitude wise. Then we have to and then we need to distinguish between these two things, whether what is the climate over Indian subcontinent and what is happening over European region. So we have to put them all on a graph basically, and then try to on a global map, and then try to see that what is happening. So if the formulation and the presentation of all measurable parameters which are directly related to the human being or the earth system, so all those parameters are studied, formulated, and presented in this branch of climatology, which is called climatography. Then applied climatology. Once we know that, of course, temperature is changing, global warming is taking place, the temperature of the globe is rising, ice is melting, glaciers are melting, everything is happening, in that case, what are the solutions? So that we have to think the mitigation strategies. So applied climatology deals with the solutions, finding the solutions of the problems of the climate change, and this branch deals with the application of the available knowledge to solve the problems of the climate. So this is called applied climatology. So these are basically the simple descriptions and very much relevant to your the subject of this webinar, 3 days webinar, like meteorology and climatology. And if you see that how you can decipher or distinguish between different situations in the atmosphere, and which branch is utilized or deals with which sort of problems of the meteorology as well as climatology. Now, so these are, for your further studies, you won't find these things in the books, and even not on internet also. So I have some sort of collections of very literature. So from there, I prepared just a note for you, for the students to follow. So this is what we just discussed, that what is meteorology and what are the various branches in details. You can go through these definitions. Like as I told you, that synoptic meteorology is basically dealing with the large scale atmospheric motions, starting from the planetary scale, synoptic scale, say few hundred to few thousands of kilometers, and then of course mesoscale motions, a few tens to few hundreds to few tens of. So these are scales written in the bracket. There are various scales of motions on the on the surface of the Earth, basically, if you deal. So there are some of the motions of the scales of planets itself. Like for example, the Earth is having a radius around 6,400 kilometers. So there are scales of motions of that order as well. Then synoptic scales, few hundred to few thousands of kilometers, and then of course mesoscale motions, few hundred to few tens of kilometers, and then small scale motions are also there. Like you see, sometimes in summer that dust is rotating at one place. Some rotation is taking, wind is rotating around some buildings in some ground. So these are small scale turbulence. We can say the example, small scale motions. Climatology I've already discussed with you. You people, can go through these slides if you are much detail. Now, let us come back to what is atmosphere now. So because this is part of the basic atmospheric science, and then we are talking about the various branches, what to study under which branch. But then what we need to understand is basically the structure of the atmosphere, structure and composition of the atmosphere, that what are the factors. So the simplest definition of the atmosphere is that it is a shallow layer of the gaseous mixture enveloping the globe with a thickness of about 1% of the Earth's radius. So 1% of the Earth's radius you can consider is around 640 kilometers in the vertical. So if I ask a simple question to any student, that what can you imagine that how far the atmosphere exists higher up in the vertical? Quite now and then, and quite often, that people going to the Mount Everest or for this mountaineering or many other expeditions or trekking, basically. So they suffer from breathing issues when they go beyond 3 kilometers or keep going to the higher. They have to sometimes carry the oxygen cylinders with them. Those people who are going to even Mount Everest and high altitude regions. So why is that happening? It means that the oxygen is decreasing in the vertical. But now you imagine that up to what height you can expect that atmosphere will be there if you are facing problem in breathing within 8 kilometers. So these are the questions for you to think. Maybe in my subsequent slides you will be able to get the answer of many of the questions. So these questions should come in your mind. Interruption. Again, of course, if there would have been no atmosphere on the surface of the Earth, we would have been suffering from very, very deadly and harmful radiation. And I think many of the species might have extincted by now. And this is, the presence of the atmosphere protects us from various harmful radiations. Sometimes it gets disconnected whenever there is a call in between. Are you getting my voice? Hello? Hello? Can somebody respond if I am audible? Okay. Okay,
Yes,
thank
sir.
you, thank you. Yeah,
Okay.
there is some delay in propagation, but anyway, I am able to, I think, get. Okay, so now the issue is the only planet which is known in the solar system is Earth. Earth is the only planet where life can sustain. So far, people have been sending many, expeditions or say missions for Mars missions moon mission, many other things have been explored or tried by the people, but still they are not able to find life anywhere else other than the surface of the earth or the from the planet earth. So these are some important. Now the question comes again that what are the factors which are responsible for existence of an atmosphere on any planet? So the question is, the answer is there are only two factors. One is the temperature present on that surface of that planet, and second is acceleration due to gravity. I mean the acceleration, or the g, what we call, is the value of on a given planet. So now, if the temperature of a planet itself is very high, so any gas molecule will, get that energy from that temperature, and it will simply escape that planet. This is, the simplest thing that we can understand. And if gravitational pull is so high that even the temperature is very, very high, but gravity can hold that, envelope or the gaseous composition on that planet, so again that gas will survive there. For example, the temperature of the sun is very, very high, more than 5000 degree Kelvin. But still, there are hydrogen and helium light gases present in the, atmosphere, or say present on the sun, which is basically the fuel for the energy. So because the pull, or the whatever, I mean the gravitational pull or nuclear pull, whatever the forces present there, they are so strong that even such an high temperature is not allowing the gas molecules to escape from the sun. So similarly, we can imagine here that on the surface of the earth, the temperature is not that high, which is good enough to allow your hydrogen, nitrogen, and any other gas to escape from. That's why we are, or CO2, mainly carbon dioxide. That's why we are having an atmosphere on the surface of the earth. If the temperature of the earth would have been very high, for example, say more than 100 degrees Celsius, so first thing, that nobody would have been there. I mean, lives which are, sustained there within, say, 30 degrees Celsius, they would have never survived. And of course, many of the gases might have left the surface of the earth. And of course, if gravitational pull also would have been even very less as compared to the temperature which is there on the surface of the earth, then also it would have survived. So there is balance between gravitational pull and temperature of the surface of the earth. So temperature of the surface of the earth or the planet will basically provide molecular velocity, or increase the speed of the molecules, whereas gravity will try to hold it back on the surface or of that planet. So these are two forces which are balancing, actually, which are responsible for retaining atmosphere on the surface of earth. Now, these are the mathematical formulations if you talk. So the velocity of a gas molecule is given by this square root of 8 kT upon pi m, where T is the temperature of that planet, you can say, if in terms of planet we talk. And again, then escape velocity is V is equal to under root 2g into r, where z is coming into picture, acceleration due to gravity. So where the acceleration due to gravity, g, will be very high, r is of course the radius of that planet, will be fixed mostly. So that means escape velocity has to be very high. And escape velocity and this velocity of a gas molecules are two competing factors. If VE is greater than V, so it will never allow the atmosphere or the molecules to leave that planet. If this molecular velocity is higher than the escape velocity, which is depending upon the gravity, if you see these two formula, try to compare. Basically, the engineering students can do this exercise, that how does it matter. It's a very simple thing. And then you will find that how the atmosphere is existing on any planet. So for example, the escape velocity of Earth is 618 kilometer per second. So if you throw anything, or if you're able to give the energy to a gas molecule so much or so high to the that it attains a speed of 618 kilometer per second. So it will leave the, basically surface of the earth, or the in general, if we can throw something with this initial velocity from the surface of the earth, it will leave the atmosphere. It will go outside the field of the gravity. Formula you can see, and basic things basically, and try to understand how does it work in the frame of a planet. So now, I just for your understanding, I have kept something for you people to understand that why there is not atmosphere on the other planet. Basics I have explained already. So this is our solar system, if you see, and Mars and Venus are basically closest to the closest orbit, the Earth's orbit. Then Venus, why people are now trying for Venus, and why people are trying to search life on Mars? Water and CO2 or oxygen, which are the components, essential components of surviving life on a planet. So there are scientists, or globally they are trying for space missions only for Mars. So these are the two factors which I've already explained in the previous slide. So now you see here the temperature on other planets. If you see the factors that why the atmosphere do not exist there, atmosphere does not exist there. So the temperature on the Mercury is very high. Therefore, if it is very high, so gas molecule will escape before, escape out of the influence of the gravitational force. So one by one, all molecule will leave the surface of the Mercury. Hence, there is no atmosphere present on the planet Mercury. So Mercury doesn't have any, atmosphere gas present on it. Similarly, if you see here, planet like Mars or Venus, these two are having controlled amount of carbon dioxide, right? So this is because that's why we can say that the surface parameters like temperatures are quite favorable, because of which there are some gases still present. Then atmosphere of the other planets consists of light gases such as ammonia, methane, and hydrogen, etc. So only CO2 is present. CO2 is actually responsible for global warming or greenhouse gas. Apart from that, CO2 is if it is present in the naturally existing amount, so it is actually good for any planet, because it keeps the earth warm. If there would have been no CO2 on the planet of the earth, the temperature of earth would have been minus 18 degrees Celsius most of the time, either day or night. So since the presence of carbon dioxide has sustained the temperature of the earth, right? So if it is sustaining the temperature of the earth up to average temperature of 20 Celsius, which is good for sustaining life or living things on the surface of the earth, this is the only reason, because CO2 is present. But man-made activities has increased the amount of CO2 to the extent where it has become a problem now. It is warming the globe at a higher rate. We are doing we are trying to destroy all sort of the sink of CO2. Sink means, like, for example, plants, trees, or forest, they eat CO2 in the daytime and release oxygen in the process of photosynthesis. But then if the amount of the forest is decreasing, every biotic life or all other things which are there in oceans are getting affected by man-made activities. So CO2 sink is decreasing and CO2 production is increasing. So that is the imbalance, and this imbalance is adding to the net increase in the temperature of the earth, and this is what we call global warming because of the CO2. Now see the comparison of the parameters of temperature and escape velocity with respect to earth at other planets. So earth is having 20-degree average temperature and escape velocity 11.2 kilometer per second, right? Whereas if you see, Mercury is having 350 degrees Celsius temperature in daytime, Venus is having 480 degrees Celsius temperature. So at this temperature, lighter gases will not survive. CO2 may be in some control amount, may be present there, but most of the gases will escape because they will attain very high temperature gas molecules, and they'll simply using their kinetic energy will move away from the surface of that planet. So this is a comparison, and going down to the from Mars is almost having temperature equivalent to the Earth. That's why people are trying. And moreover, if you see on the surface of the Mars, CO2 is 95%. whereas on the surface of the Earth, 78% is nitrogen. So, and nitrogen is only 3% there on the Mars. So these things are, these are the factors. And oxygen is 0.1%, whereas we are having 21% oxygen. So surviving life there or what kind of a species is a very far cry now. But still people are trying to explore that, is life possible there? So this is the main point. Now Jupiter is minus 110, minus Saturn minus 180, Uranus minus 216, Neptune 216. All are, and Pluto is minus 200, minus 223 degrees Celsius temperature, it's very, very difficult, almost impossible to survive. Now, coming back to the Earth's atmosphere. So atmosphere is classified based on two factors. One is the composition, other is temperature. So composition, basically water, if you try to collect one sample, fill in a bottle and try to take it in a laboratory, and then try to analyze that through various available technologies. And then you will come to know that Earth's atmosphere is having 78% nitrogen, 21% oxygen, and everything else like inert gases, carbon dioxide, water vapor, carbon monoxide, nitrogen, other oxides of nitrogen, anything else that you can imagine, or the gases which are present in the atmosphere. Basically, based on the composition, you will find that everything else other than nitrogen and your oxygen, everything else comes in 1%. So this is we call composition, chemical composition, gas composition. Now, second thing, the second point is, if you see that now, as I asked you in the very first slide, I asked you a question that what is the vertical extent of the atmosphere? What can you imagine that even people, if people start feeling very difficult to breathe at, say, around 8 kilometer or around 9 kilometer, 8.5 kilometer, then how far can you imagine that how far can a person go higher up in the atmosphere that he will be able to survive without having the normal composition? So now so this is the other part. We understand the vertical structure of the atmosphere comes in thermal structure or the temperature structure of the atmosphere. So the atmosphere is classified in two categories. One is based on the composition, where we know that what is the content, chemical content of the atmosphere. The other is what is the vertical structure of the temperature. That when we go up, like for example, when you are in Delhi on the same day, you are having 20-degree higher temperature than what you are having in Pithoragarh or say DD Hut, or even you go to the higher altitudes. So it means what is happening when you are going from Delhi to Pithoragarh, temperature has to be means technically it has to increase because you are going close to sun. If you go to Mount Everest, which is 8,800 meter from mean sea level, so the temperature has to be higher because you are going 8 kilometer close to sun, but that is not happening. Why? So these are the questions that will be addressed in the subsequent slides. Based on the composition, if you see that I just discussed that 78% is nitrogen, 21% is oxygen, and 1% is everything else. CO2, argon. Argon is the most, abundant component in terms of inert gases. However, there are neon, helium, krypton, other gases also. So, but then all these are in 1%. And if you see that oxygen and apart from oxygen and nitrogen, carbon dioxide is even less within 1% composition where all gases are there. But still, if you see 380 ppm, in general, if you talk the carbon dioxide in ppm means parts per million. If you take 1 million, molecule of air, so you will find only 380. 1 million means 10 lakh. 10, out of 10 lakh, 10 lakh, molecules of air is mixture of everything. If you try to collect 1 lakh or 10 lakh samples, you will find only 380 samples having CO2, one molecule in each sample. So 380 samples out of 10 lakh samples will be having CO2. And if you see influence of CO2 on the surface of the earth and in terms of the global warming, it is so high that we have to about the global warming or the issues of the climate change are cropping. This is effect of these gases. Methane is a greenhouse gas. It is present in 1.75 parts per million, whereas CO2 380. Ozone is again a sort of greenhouse gas when it is present in the troposphere. When I talk about troposphere, there I'll be discussing about good ozone or bad ozone. So now, I mean, over 200 years, this 40% increase, if I'm quoting here. So it is found that over past 200 years, the content of carbon dioxide, which has been released through man-made activities in the atmosphere, has gone up to 40%. So see, whatever carbon dioxide was present initially or say in the natural environment, it has gone up by 40% in past 200 years. So if it has gone 200, I mean 40% up in 200 years, so you can imagine the impact just within 200 years that globe is warming, poles are melting, even the ice shells which have been formed there on the poles, say millions of years ago, and through very long process, they have realized the heat, and they are so sensitive to the global warming that they have started melting down, breaking down, and they have given 20 centimeter rise to mean sea level within 200 years. So you can see. So roughly, I mean, if I try to find it a linear relation, so 100 years means you can say that 10 centimeter in 100 years, the sea level will rise by 10 centimeters. So 10 centimeter rise in sea level is definitely going to harm you to the extent you cannot imagine. And as the globe is warming, these melting rates are increasing. These are not linear. These are mostly non-linear. And there are cases when within Arctic region, when within say 3-4 days, the melting has gone to the level of say which has not happened over say 50 years. This has also been seen. There are reports. So this is kind of the impact in the composition of the atmosphere the CO2 can have. So that is why we call it a prominent greenhouse gas. Dominant greenhouse gas is CO2. Methane, ozone, all other gases are also there. But then oxides of nitrogen, which are being emitted through fossil fuel combustion, industrial emission, all sort of the atmospheric air pollutants. So all these air pollutants are adding to the atmosphere, and they are trying to disturb our natural composition. And that natural composition mainly within that 1%, which is playing very significant role. So I mean, once you can have sort of discussion on these issues with me for hours. I have yeah. So these are the kind of the issues that you can look into, and we can have discussions, as I told you, that for hours together. But then since we have a limitation at the moment, and I need to, what happened? Okay. So now we come to the second point, thermal structure of the atmosphere. So thermal structure of the atmosphere, if you talk, as I told you that the average temperature of the surface of the earth is 20 degrees Celsius. And if we start from 20 degrees Celsius, say from mean sea level temperature is 20 degrees Celsius, globally average. It is not like, at Pithoragarh maybe nowadays 5 to 6 degree, or average if you take maybe 8 degrees Celsius. But at the other times, at the same time, if you go to Trivandrum, it may be around 32 degrees Celsius, but average, this is average of the globe. So these here see here, if I see, this is a line which is showing a decrease in the temperature, then again increase, then decrease. And so atmosphere is divided in 4 spheres in the vertical. The lowermost is troposphere, then there is a 1 to 1.5 kilometers pause in between, where temperature is not increasing or decreasing, it is almost stable or say slightly increasing. So we call that tropopause. So the lowermost there, the sphere of the atmosphere is troposphere. This extend, I mean, this is a picture for mid latitude, but when we talk about tropics, where we are staying basically tropical region, 30° north to south, so the troposphere extends from surface to about 18 kilometer. This is somewhere around 18 kilometer, but mid latitude it is about 12 kilometer, and if you go to the poles it is about 8 kilometer, 6 to 8 kilometer tropopole. So the first sphere of the atmosphere, the lowermost, is troposphere, where almost everything happens, all activities, all weather phenomenon, everything. And mostly if you see that these are the flights which are passenger aircrafts, they fly around tropopause, or 10 to 12 kilometer we can say, not tropopause. But if you see the fighter plane, they can fly up to around more than 20 kilometers. So fighter aircraft fly in the stratosphere. So before, I mean, going into detail, I'll just say that atmosphere is having four spheres. The lowermost is troposphere, which extends from surface to around 18 kilometers for the tropics. Then other sphere comes stratosphere, which is very rich in after tropopause it is stratosphere. So stratosphere extends from tropopause to stratopause. Pause is a layer between where the one sphere gets over, finishes, and the other starts. So then stratosphere is extending from around say 17 18 kilometer to around 53 kilometer. Then there comes another sphere, which is mesosphere, which extends from 53 to about 90 kilometer. And then above 90 kilometer, if you see, this is thermosphere, then where the temperature consistently increases. So now here you see that temperature started from 20°, and as we kept on going up to tropopause, temperature started decreasing. So why does this happen? Temperature, the decrease seen here, that if you talk, I'll just give you some sort of science behind it, that why the Delhi temperature at the same time is higher than the temperature at Pithoragarh. Since we are talking, it will be relevant to talk about Pithoragarh, because as we go higher up, the atmosphere decreases, right? The atmospheric composition decreases. Density basically, um, if you talk about density, so if we write down a formula, rho is equal to rho naught e raised to the power minus j by h exponential. So temperature density of the atmospheric composition decreases in the vertical exponentially. So if the density of the atmospheric composition is decreasing, so it means what would happen? The solar radiation, because the solar radiation which is coming on the surface of the earth is only visible light. Other radiations, say stratospheric ozone, stops almost all radiation there. And whatever radiation it comes on the surface of the earth, to which atmosphere is particular, I mean, in particular trans for visible wavelength, that visible light is absorbed by all materials or objects on the surface of the earth, and then re-radiated into long wave outgoing radiation. So since the density at the lower height will be higher, so more radiation will be trapped in the lower heights, or say lower regions, because CO2 content will be more, and they will try to trap all those radiation in the lower. So therefore the temperature at the lower heights will be higher. So this is one simplest region. So again, pressure also decreases, because the whatever pressure we are feeling on the surface of the earth is a columnar pressure. For example, whatever material is there on the surface of the earth, and we consider a column of unit area or unit volume, you can say, in the vertical, so that is distributed in that column in the order like rho equal to rho naught e raised to the power minus z by h, means exponentially. So the higher mass is at the lower level, heavier gases are at the lower level, you can say, arranged higher atmosphere. So because CO2 is a heavy gas, you can say, as compared to the hydrogen and nitrogen and other, so they will arrange in such a fashion that the concentration of CO2 definitely will be higher at the lower levels, lower altitude. So that is where, because CO2 is trapping more radiation at the lower level, so temperature is higher at lower levels. So now, if you see this curve, at what rate it is decreasing? It is decreasing at the rate of 6.5, roughly 6.5 degrees Celsius per kilometer. So when you go 1 kilometer high in the atmosphere, or I can say that if you climb 1 kilometer mountain in the, climb up on a mountain of 1 kilometer high, you will see that temperature difference of 6.5 degrees. We call it atmospheric lapse rate. So in the troposphere, temperature decreases by 6.5 degrees Celsius, in 1 kilometer. So you can imagine that at Mount Everest, what will be the temperature, or at tropopause, what will be the temperature. You keep decreasing, starting from the surface of the earth, you keep decreasing at the rate of 6.5 kilometer, per degree Celsius per kilometer. You will see that uh, you have reached 0 degree within, say, 3.5 to 5 kilometers, somewhere between 6 5s are 30. So 30 degree within 5 kilometer, 30-degree temperature will go down. If you are sitting over Delhi, so I mean, from Delhi to getting a 0 degree temperature in summer, you can say that within 5 kilometers, if you go up, you will reach 0 degree temperature in the vertical. So that is the reason that with the exponential decrease in pressure and density, temperature also is bound to decrease and we call it lapse rate. In the stratosphere, temperature you can see start increasing because stratosphere is ozone-rich region, and ozone absorbs all ultraviolet radiation and increase the molecule of the temperature. Increase the temperature of ozone molecule, and that gives. But still, you can see that even the temperature is increasing, but it is not coming, at the tropopause close to zero. It is sub-zero. So increase is not positive. I mean, of course, ozone is increasing the temperature of the stratosphere, but it is still cool. And then again it is start decreasing in the mesosphere, because there also you don't find much of the radiation going back from the surface of the earth, because the atmosphere is heated from below, not from the top. The outgoing long wave radiation, whatever going from the surface of the earth, after being absorbed, the white light is being absorbed, and every material has its own black body radiation spectra. So whatever it is absorbing, it increases its energy and then re-radiate in the other wavelength, which is outgoing, which is responsible for heating. So reaching to such an height, the backscattered or the back re-radiated outgoing wave radiation, it reaches hardly to these altitudes above 50 kilometer, and that's why the temperature also decreases continuously. But again, if you see here, after 90 kilometers or so, you will find that thermosphere. Thermosphere is basically completely ionized media and very, low density medium, where you will find only plasma, ionized material only. If the hydrogen molecule or hydrogen atom is present there, it will be there in ionized form. So electrons and, ions only. So there also, so this is not actually the temperature. This is basically in terms of the electron density. If you talk about that, the temperature, so electron density increases there basically. That's why we call it a thermosphere. Temperature is increasing, but this extends up to 600 kilometer roughly. So this thermosphere extends from 90 to 600 kilometer, and it means after 600 there is practically no plasma, no electron, no ion, nothing present after 600 kilometers. It is only space. That's why if you see that all weather satellites are established in the orbits above 500 kilometers, where practically no matter is there present in the atmosphere to interact with the satellites, and whereas the communication satellites are kept at the heights above 18,000 kilometers, 18,000 to 36,000 kilometers. So these are some salient features about vertical structure of the atmosphere. So atmosphere, what we simply talk about is not that simple. If you try to study atmosphere, so all these spheres are one complete field of research, and they are divided into upper atmospheric research and lower atmospheric research. And there are specialists for these areas also and subjects in various institutes. So I mean, this is just a slide to give you a basic idea that how the thermal, how does the atmosphere works and what are the structure basically. So you have to remember these two things based on composition and based on the thermal structure basically, which is related to the temperature. So now here all these things, and now one more important thing, you can see that 99% of the atmosphere is confined within 40 kilometers. So you can also ask the question that how far pollution can travel up into the atmosphere. So I'll simply say you that all sort of aerosol or the particle, dust, anything which is hanging in the atmosphere is most likely confined in the most of the time within 6 kilometers. So they cannot penetrate atmosphere above 6 kilometers. And in the nighttime also they come within 1 kilometer. They settle on the surface of the earth. And the most of the weather processes, as you understand, that everything happens in troposphere. So a lot about that also. There are many other issues, but we have to complete it within the time also. So these are some of the salient features of atmosphere. Again, there is one more sphere which we call ionosphere.
आज 28 का निकालो, देखा तुम्हें कितना आइडिया है।
Hello.
रहेगी तो तुम भी एक्सपर्ट हो गए हो यार नवीन, है ना, इसी में है।
So I think there is some disturbance in between. Audible, Negiji? Hello. So, ionosphere is another part of the atmosphere basically, which is partly some part of mesosphere and other as thermosphere. So 30 kilometers of last 30 kilometers of thermosphere are basically we call this D layer region. Then 60 kilometer to 120 kilometer is E layer region, and then 120 to 180 kilometer is F layer region. So as the composition of the atmosphere changes with height, the ion production rate also changes, and this leads to the formation of the several distinct ionization layers or the peaks. We call them D, E, or F layers. So of course, then these are some wind and scales of the motion in the atmosphere. Thousands of kilometers, like winds are blowing from west to east, say up to thousands of kilometers, we call them planetary scale motion. Then synoptic scale motions, basically a few hundred to few thousands of kilometers, like monsoons, western disturbances, squalls, eddies, cyclones, etc. And then mesoscale motions, basically few tens to few hundreds of kilometers, like waves, eddies, jet-like features, frontal zones, and thunderstorms, like what we see, thunderstorm or cloudburst even sometimes they are also mesoscale motions. So this is, I mean, a brief, just to an idea for you people that what we do at Aries. So atmospheric research, we are doing basically aerosol measurements like distribution and then black carbon, various other volatile organic carbon studies also. And then trace gas measurements also we do at Aries, which are known is one of the trace gas or say greenhouse gas, oxides of nitrogen, non-methane hydrocarbons, carbon monoxide, etc., etc. And my specialization basically is in micrometeorological measurements, meteorology more or and modeling. So I deal all these issues and vertical the atmosphere using lidars, radars, and of course meteorological instruments. So students, those who are interested to carry out some projects to interact anytime, they can always contact me. And of course, we can do some interesting studies together, and you can take part in activities of measurement and of course some computing issues or modeling sort of things. So, I stop here, and there are a lot of things to talk for hours, but then what is actually bare minimum we can make understand people here, I would go with that. And questions are welcome. I hand over it to the moderators. Thank you, and once again thank you for being there and listening me patiently to all students. Thanks.
Hello.
Hello.
Hello. May I audible, sir?
Yeah, I am able to listen you.
Okay, good afternoon. So I have a doubt.
Yes, please.
What the
Hello. Yes, you please go ahead, or you can write it down to the moderator. They can speak. You are if you are not able to, connect.
it will go increase in the temperature sometimes initially increases. After it means sometimes minus something degree comes. And after the stratosphere, temperature suddenly rises and then it will decrease.
Hello. Then somebody out of the moderators can take up the questions and communicate to me directly. I mean, through audio, because I think some students are trying to ask something, but I am not.
Yes, sir.
Nigzi, can you take up the question? If the students, I mean, they can write their question in chat. I am new to this, so I usually use Zoom and other Google Talk, etc. So I don't find here.
Audible, sir.
Yeah. Go ahead, please.
Okay, sir. So my question is that if we
Yeah,
the
what is your
temperature
question?
go
Go
on,
ahead. If
initially the temperature go on decreases,
uh,
it is increase in the altitude,
uh,
stratosphere. Beyond stratosphere, the temperature increases.
yes, if temperature decreases, then what? What is your question?
Beyond stratosphere, temperature again increases. So what are the reasons for that?
Again increases? Hello?
From the graph, what it was shown, stratosphere increase
Yeah.
in altitude, the temperature go on decreases. Beyond stratosphere, it is again increases the temperature.
Right. So this is what I told you, that ozone, the stratosphere is abundant in ozone. In stratosphere, the most of the ozone is present in stratosphere. So stratosphere basically doesn't interact with the visible light in general, but they are very much they straightway absorb this ultraviolet radiation which is coming from the sun, because sun emits an entire band of radiation. So whatever radiation is written in that stratosphere, so stratosphere basically the ozone present in the highest concentration is between 20 kilometer to 25 kilometer. So within this 5 kilometer, you say most of the radiation is absorbed, or of course there is a distribution of ozone in the entire stratosphere. So stratospheric ozone takes that energy of ultraviolet radiation and increases the temperature. This is the reason. Go little slow, because you are not audible. There is break in your voice. I think the best way to interact would be, I mean, my next lecture, I would suggest you all put your questions in the mail or in a chat box, and at the end, the moderator of the session will ask, read your questions, and I'll be able to answer, because what I'm seeing that your voice is not coming clear. You want to ask something. I'm. Can you ask? Can you repeat your question? Because yeah.
Sir, I have a question and I will understand the answer what you have delivered. That due to presence of the ozone gases,
Yes. In the stratosphere, yes. The previous.
yes, absorb the ultraviolet rays, that's why the
Yes.
temperature increases.
Right.
Thank you.
Okay.
Thank you.
Thank you, sir. Thank you, sir, for sharing your valuable knowledge with us. It's been a wonderful session. We all have gained a lot of knowledge with the session. Okay, any other queries, participants? If you have any, you can write them in the chat box and I'll announce them directly. Read them. Any queries from the participants? Okay, so I can still queries.
Yeah, even you can collect
Can-
the questions of the students can collect in written one. Or even students are really interested to learn more.
Right, sir. In your next session, we will.
Sure. But there is quite often disconnectivity. I don't know whether at my end or at your end.
So I think at our end the connectivity is okay.
Okay, so maybe yeah, sometimes at my end, maybe the.
Okay. Thank you, sir. Thanks a lot.
Thank you so much. You, all your entire team and all members of LOC, Local Organizing Committee, who thought of this very, my heart, and I would be really happy to interact with the students anytime, and with you people also who are interested in atmospheric sciences or say meteorology, climatology, and all sort of issues which are related to directly and indirectly climate change. So I'll be so happy to join hands with you people always. Thank you so much.
Definitely.
Thank you for inviting me.
Thank you, sir. This is to announce to all the participants that our next session will start from 2:30. So I request all of you to please join the session at 2:30 after the break. Thank you.
थैंक यू नेगी जी चलिए
नमस्कार